Okay, so that was the last lesson. Let's have a look at another spectrum of another compound. So 1H Spectra NMR for, let's think what it would look like for butanone. Okay, so butanone has this structure, has this formula. It has CH3, CH2, C double bond O, CH3. Okay, so let's have a think about how many different hydrogen environments have we got here? Well, we've got these three hydrogens are obviously the same, all stuck to that carbon. Are they the same as these ones? No, they're not, because these ones are next door to a carbonyl and these are next door but one. So this lot, these three are going to be different. And then we've got those two there, they're going to be the same as each other. So that would give us 3 peaks. So we'd expect to get 3 peaks, yeah. What would be the integrated values? So in other words, the area under the curve. Right, so the red hydrogens, well, how many of them? Most of this, so there'll be 3 there. The yellow hydrogens, there's 2 of them, so that would be the 2, that would be slightly smaller peak. And then the green hydrogens, there'd be 3 again. Okay. Let's have a think about the splitting, okay? So each of those peaks will be split, or maybe split, and let's have a little think. Now let's have a look at the red one, okay? The carbon next door has got 2 hydrogens on it. So the n+1 rule, so the red ones are going to be split into 3, into a triplet. The yellow ones, right, if you look at them, right, the carbon, there's 2 carbons next door. This one hasn't got any hydrogens on it at all, but this one has got 3. So that's going to be split into 3 + 1, a quartet. These green hydrogens, they are attached to a carbon with no hydrogens on it at all. So 0 + 1 makes 1. That's not going to be split. That's going to be a singlet. So we're going to get that. And finally, the ppm. And you don't actually need to know the ppm values. You're given to them in a chart, but just there's not that many, and you probably remember the most important ones anyway. Right, these red hydrogens, these are well away from the electronegative oxygen, so that always means you have a ppm of about 1. So just put away from electronegative elements. Those yellow ones, right, they will have because they are next door to a carbonyl, that usually gives things a ppm of about 2. Because it's next to a carbonyl. And that's a really important one. You'll probably remember that. And that means, well, you can look at the green, that is also going to be a ppm of approximately 2, because they're next to a carbonyl. So if you, I'm going to sketch what this was put through an NMR machine, what would the spectral look like? It would look something like this. Okay, so ppm scale. Okay, and on this scale, you've got increasing absorbance of radio waves. Well, we're going to get the yellow one is going to give us a triplet, and that's going to be about 1 ppm. So the triplet would look something like that. The green ones, that's going to be a singlet, and you'd probably notice that would be quite high. We'll talk about why that's quite high in a minute. And the yellow ones, that's going to be a quartet. So that would be okay. So that's what your spectrum would look like. Just a couple of little things there. The integrated value, you can tell it's very, once you get splitting, it's very hard to guess what the area under the peaks is just by looking at it, and that's why the spectrometer works out the integrated value. I'll just write it on there. So it's got an integrated value of 3, that one's got an integrated value of 3, and that one's got an integrated value of 2. The green peak, because it's not split, it's going to be very tall because the area is still going to be quite big. It's going to have an area under 3 in it, so it has to be pretty tall. The quartet, this one here, let's have a look at that. Right, now you may think, why the green and the green and the yellow, why shouldn't they I said they should both have a ppm of about 2. Well, you'll notice that normally whenever you have a CH2 hydrogen, it's always got a slightly higher ppm than if you have a CH3 hydrogen. So that's why this one would actually be slightly to the left of that one. Don't worry too much about that. So that is what your spectrum for butanone would look like. Before we finish, let's have a look at what the 1H spectra for pentan 3-one would look like. So let's do that. So pentan 3-one. So that's going to be CH3, CH2, C double bond CH2, CH3. Now we talked about this in the first lesson, I think, and there's symmetry in this molecule, isn't it? So those 3 hydrogens would actually be the same ppm, be the same peak as those 3. That will give you 1 peak. And these 2 hydrogens are in the identical environments of those 2. So this is only going to give us 2 peaks, this molecule, isn't it? So let's look at the integrated values. Okay, so that's the red ones there. There's 6 hydrogens there, so it's going to give us an integrated value of 6. And the green, there's 4 of them, so that's going to give an integrated value of 4. By the way, whenever you see integrated value of 6, you've got 6 identical hydrogens. Well, you can't have 6 hydrogens stuck onto the same carbon. It's impossible, isn't it? So it usually means you've got 2 identical CH3 groups if you get that. Likewise, if you get an integrated value of 9, it means you've got 3 CH3 groups in the which are identical to each other. Right, now we need to talk about the splitting. Okay, so the red one, right, if you look at those hydrogens, look at the carbon next door. There are 2 hydrogens next door, 2 plus 1 makes 3, so that's going to be a triplet. And of course, it's going to be exactly the same on this side. These, okay, that's going to be a triplet, but it's going to be superimposed over that one. They're identical. The green, well, if you look at that, this carbon has got no hydrogens on it at all. So forget about that. This one's got 3, so that's going to be a quartet. And finally, we need to think about the ppm, chemical shift. Now the red ones, they're a long way from any electronegative element, so that is going to be ppm of approximately 1. So away from electronegative elements, whereas the green one, they are going to be about 2 because they are next to a carbonyl, and that is oxygen's electronegative, so it tends to push the spectrum a little bit upwards. So let's just sketch that, what it's going to look like. So we've got Okay, so we're going to have a triplet here. And we're going to have a quartet. That's going to be about 2. So that's what our spectrum for penton 3A is going to be. Look at a triplet and a quartet. Integrated value of 6, integrated value of 4. Okay, more examples to come.